Welcome to Lecture 0 of ECE 1786, Creative Applications of Natural Language Processing. My name is Jonathan Rose and I'm the instructor in this course. The reason I've put out this video, Lecture 0, is twofold. First of all, I'd like you to know what the course is about so you can be sure that you want to take it. But secondly, this course is built on other knowledge in the field of machine learning that I need to make sure that you understand you need to have. In our department, we don't have a way to enforce prerequisites for a course, so in this video I'm going to tell you what you need to know and then ask you to fill out a survey so that you can figure out, and I can figure out, if you should stay in the course. Our tradition here at the University of Toronto is to begin courses with land acknowledgement. Toronto is a city of immigrants, and my parents arrived here way back in 1952, and it's likely that you or your parents are new to this country. This is not a new feature of Toronto. For over 15,000 years, Toronto has been a gathering site for humans, including the Huron-Wendat and Pedon First Nations, the Seneca, and most recently, the Mississaugas of the Credit First Nation. Today, Toronto is still a meeting place for Indigenous people and immigrants, both new and old, from across the world. I want to acknowledge our duty of stewardship toward the land, and I'm very grateful to have the opportunity to work on this land. Welcome also to ECE 1786. This course is about methods for the automatic understanding of and generation of human language. Language is a deep and important thing. We use it every day, and it is the pathway into and out of our brains. And it is, when we start talking about automating it, we're getting close to real intelligence. And I think until recently, it was very difficult to connect humans and computers. They really, with language, because language is such a deeply human thing, and it just didn't work. And in this course, we'll cover the inventions that have made sophisticated communication possible and has also led to other remarkable capabilities. I look forward to, perhaps not in mine, but in your lifetime, to be able to talk to a computer-based doctor and get decent basic medical care and have that true for everyone. So I think not so long from now, maybe, you'll be able to talk to a computer, whether it's your phone or a laptop or whatever, and say, I don't feel good. And the computer will say, well, what's the matter? And you'll say all the things you would have said to a doctor, and it'll be good because once we make it good, everybody gets a good one, I think, in this world. And near and dear to my own heart, I think, is also taking that same notion towards mental health care talk therapy, that you'll be able to talk anytime, anywhere to something that has good knowledge of how to talk and engage with known good therapies. In fact, my current research focus is all kind of circles around that last point. We focus a little more narrowly on smoking addiction. We'd like to help people move away from their smoking addiction using talk therapy, and I collaborate with people who do that for a living here in Toronto, in the mental health hospital. And here, hot off the presses, is something that came out a week and a half ago from my research group, using GPT-4o as the basis for a chatbot to deal with a real smoker who and use the known good therapy method, or at least some version of that known good therapy. You know, our bot starts out by just asking for small talk by saying, thank you for choosing to speak with me today. I'd like to understand what's been happening in your life, any significant events, experiences, or changes that you'd like to share. So this is generated upon our prompting of the bot. This particular user seemed to want to smoke. This is a real user who is a smoker that we deployed this to, who wanted to type in all caps, so I'm leaving it in all caps. And the user jumped into the smoking question and said, smoking makes me feel good. And the bot, trying to apply a methodology that we taught it some about it and already knew about, called motivational interviewing, said, well, it's clear that smoking has a significant impact on your feelings and well-being. What do you think it is about smoking that brings those positive feelings? This is employing a key part of the known therapy to get people just thinking about their addiction. User says, the way I feel after smoking. The bot says it helps shift your mood or state of mind. The bot is guessing. That's what it's supposed to do. How does this feeling compare to other ways you might manage your emotion or stress? And I just want to point out, this would have been impossible 2.5 years ago. And it is amazing that the simple way we asked GPT-4o to do this does this well. It's not perfect, and the conversation goes on. I won't read it more, but this is the world that we have launched into, and I never believed when we started our project that this kind of thing would be possible, and much more is possible. And some of that's the basis for what I'm going to teach in this course. I first taught this course starting in November 22, and I was 3/4 of the way through it in November. And the course was, as I've briefly described, it's on how large language models can be used to generate and classify language. And at one point I was showing, prior to November, I was showing how GPT 3.5 was doing remarkable things. I was amazed at what I was able to do with it, answering questions, giving creative outputs. And then in November 2022, ChatGPT was released for free, possibly one of the most brilliant marketing tactics of all time, because the world woke up and said, what is this? And perhaps that's why you're interested in this course. And I'll be interested to know how often you use ChatGPT for various reasons. In March 2023, GPT-4 was released, and it was a whole leap better. We'll talk about that and the measurements that were made that showed that. More recently, 4.0 and others from elsewhere are better still. The rate of progress of these models has been absolutely stunning. The quality, the modalities that they can handle. I mean, we're mostly going to focus on language in this course, but there's pictures in and out, video in and out, and sound in and out, and which is amazing. That's different modalities, and the price has been plummeting, actually. I was looking at something today that was an innovation that actually we'll learn about in this course that brought the price down dramatically if you're doing repeated calls. All that said, we're still in the process, the world, are still in the process of understanding what these large language models can do, how to prompt them. And one thing that I want to focus on in this course towards the end is how to decompose problems that maybe don't work with a single instance of a large language model, but maybe multiple instances that are talking to each other can do even more sophisticated things. And another crucial thing that'll go on in this course is how to figure out if what's coming out of the models is right or wrong, because it can be wrong, and maybe to figure out what's brilliant about it, because there does seem to be remarkable things going on. So the course is about how these large language models work and how to use them, all in the context of what has been called natural language processing. And let's just spend a moment on talking about why language is a difficult thing to deal with. Well, language is incredibly ambiguous, particularly the English language, but all languages. There are multiple meanings of the same word. Think of the word tank. It is both a verb and a noun, and it has completely different meanings. Same with bank, same with duck, and lots of other words. So it's a simple, ordinary processing has difficulty with those. And you need contextual knowledge to figure out things like a sentence which says milk drinkers are turning to powder. This doesn't mean that some humans are becoming powderized. It means that the kind of milk that people are drinking is changing to be based on powder rather than liquid coming from its original source. And these are 3 other examples that you have to read carefully and know a bunch of things about, including this statement, I saw bats. You need to have some guess as to context that isn't obvious, that made processing of language difficult. But now language is much, much easier to deal with. And it's all due to neural network-based approaches to natural language processing. And this has been helped since the deep learning revolution began in 2012. Began in that building right behind me, actually, which is kind of a neat thing to say here about the University of Toronto. And a key step, something called neural word embeddings, also occurred right around that time, not here, but somewhere else. The key next steps for natural language processing occurred in 2018. The transformer architecture, described in a paper published by Vaswani et al., was the thing that enabled much larger models to be built and trained. And that unlocked a flood of invention, starting with something called BERT from Google, the GPT series of models, GPT-1, 2, 3, and 4, and now 4.0, and then some, all kinds of other ones, one called Bloom, one called Lambda, it's a little bit old. There's Llama from Meta. There are more coming every day that are gaining in capability, reducing size and cost. It's just incredible. This has brought success in translation, classification, dialogue generation, automatic coding, composing essays. I'm sure you've all used it for that already. Planning projects, all based on this transformer architecture. This is the output of ChatGPT's picture generation. It doesn't quite spell things properly. I asked it to draw a picture of the transformer architecture, which will be going on in detail in the course. Now let me talk about a few of the related courses and the focus of this course, so you get some sense of where it sits in the set of offerings here at U of T. Our focus is on neural network approaches to NLP. But NLP, natural language processing, is a 6-year-old field which previously used, let's call it a procedural programming methodology, that ordinary, functional, step-by-step procedural programming. And it was based on a human understanding of language, and it has been referred to as the field of computational linguistics, although now that's come to cover everything. But the old kind of NLP talked about grammar, like the parts of speech, such as a noun, verb, or an adverb, or an adjective. And it would think about those things and structure its understanding of sentences based on that. And it would use what's called parsing of language to interpret. Parsing was always used to bring in computer languages like Python or C or whatever, or Java. And they would parse word by word and create tree-like structures to describe what was being said, or what was wanted to be said. And the course, CSC 2501, the graduate course, which has an equivalent undergraduate course in computer science, computational linguistics, focused in this area. And it is principally taught by Professor Gerald Penn. Although as I look at this course, it's evolved a lot in the direction that really is the one that works better. We will reference some of these notions of grammar and such things, but not much, actually. They don't turn out to be nearly as important, although a good coverage of natural language processing would touch this stuff. And it is covered in the textbook that we'll be using. There's a second course over in computer science called Natural Language Computing, which is closer to this course. It's previously taught by Professor Frank Rudix. I believe Professor Penn and perhaps some other new professors in computer science also taught it. It has a very broad coverage of topics surrounding language. I would say it's a superset of this course and touches things including Markov models, entropy, automatic speech recognition, retrieval of language, and dialogue. And we'll touch some of that, but not much. ECE 1786, this course focuses more narrowly on word embeddings, deep learning, what I'll call statistical language models, and transformers. So much more depth and less breadth. And it has more of an engineering and software focus. These are the key learning outcomes that I see for you in this course. I want you to understand what a word embedding is and what embeddings are from a deeper perspective, how that's used in classification tasks, and then really go into depth of the transformer neural net architecture, its global structure, most crucially how it's trained. How does it get so smart? And this thing called attention and the stack of transformer slices, how classification is done, how auto-regressive generation is done. Something that really matters in this whole world is called instruct training. It's linked. It's a different part of the training that's quite important. The notion of prompt engineering. How do you get a model to do what you want it to do? By talking to it. Something that I still find remarkable. And then something that you might not be aware of, but I think is absolutely crucial, something I'll call the agentic approach. That is, rather than having just one large language model instance do something, it might not be able to do that, but maybe breaking the thing you want to do into pieces and getting multiple LLMs to communicate as agents. And that could be, I think that is the future of certain kinds of programming, and I want that to be an important part of this course. Of course, you're going to have to learn PyTorch if you haven't, and Torch Text. Make use of the remarkable resources on the Hugging Face website. And quite separate from that is learning how to navigate a large, open-ended project by navigating complex problems and forming it into a project. That is what engineers do. We solve problems for people, and I think learning to be an engineer should involve that, and for sure that's a big part of the course, on top of all this other stuff. Let me talk about those prerequisites. There's things you have to know to take this course, and now I've taught it for the third time, and I've seen each year people have come and they did not have the background, and it just doesn't work for them, and they have to leave the course. So I'm trying to prevent that early on, and in fact I'm mandating that you fill out a survey that tells me what you know and lets me figure out if you should stay in the course. So this was flagged to you in the description of the course. It says right up front that there are prerequisites that are among these courses in U of T, APS 360, 311, 324, or 1530. These are undergraduate courses. This is a graduate course, and there's more that I'll go into in a second, or equivalent. So these are courses that teach you the basics that you must know in order for this course to make sense. It would not be possible to teach this course if I didn't rely on the fact that you knew these things already. So what are those things? Well, the course does not introduce machine learning. You must have a background from a course in machine learning that has some depth in neural networks. As I say, you won't be able to understand the assignments. I listed those U of T courses, ECE 324 in the engineering science program, ECE 421 in both engineering science and ECE. APS 360 is available to all undergrads in engineering, applied fundamentals of deep learning, and CSC 311 and 413 are also good background courses. And the graduate courses that are like this, ECE 1513 is pretty good on this. MIE 1517 is actually similar to APS 360 at the graduate level. And a new version of ECE 1508, and I want to flag there are several 1508s. There was one on reinforcement learning this summer. There's one being taught right now that's called Applied Deep Learning, and it is going to be similar to 1517 and APS 360. And so those courses, or something equivalent to them, are what you must have for this course to make any sense at all. If your undergraduate degree is from elsewhere, not from U of T, and that's many of you I know, you must have taken a course that's equivalent to that. And I'm going to go into detail in the next few slides about what that background is. And then I'm going to ask everyone to fill out a survey, which is posted on the course main website and elsewhere, in which you'll tell me the courses that you've taken and provide links to non-U of T courses. And I'll be asking you some questions that you'll need to answer from your own knowledge. About that background. More generally, these are the things that you need to know already. So you need to know what machine learning is. What is classification versus regression as a basic notion? And that would include knowing what logistic regression is versus linear regression. You should know what binary versus multi-class classification is, what supervised learning versus unsupervised learning is, and what it means to label data, because that's going to show up a bunch in this course. You need to know the basics of neural networks and how they're trained, what a linear neuron is, its weights and its bias, what a nonlinear activation function is, like sigmoid and ReLU, what a multi-layer perceptron is. If you don't know the term, you might know what it is by looking it up. What a loss function is, such as binary cross-entropy or multinomial cross-entropy or mean squared error. What the softmax function is. What the training, validation, and test set is. If you don't know what that is, you cannot take this course. The basic notion of how you ensure that your neural network can generalize, and you do that by looking at training and validation curves. And you may know these by other names, but you must know these things. You must know what gradient descent is, as a general case, and the distinction between that and stochastic gradient descent is fundamental to how all this deep learning actually works. You need to know what a hyperparameter is in those networks and how you might tune them. And the notion of regularization. 3 ways of doing regularization or normalization, dropout, and weight decay. These are things that get covered in those neural net courses. You should know something about advanced neural networks like convolutional neural networks for computer vision, CNNs. We're going to leverage that in assignment 2 in this course. It means you've got to know what a kernel is, what batch normalization is. It's good to have some knowledge of a recurrent neural network, although we won't touch much on them in this course. Super important, a sort of fundamental thing built on top of all of that is transfer learning. You're given a pre-trained network. How do you fine-tune it to do something that it wasn't originally trained to do? That will show up big time in this course. Those are the notions, but that's not enough. You need to know how to build all that. You can't have just studied it theoretically. You have to have built software within real software frameworks, either TensorFlow or PyTorch. Those are the 2 big ones. This, of course, implies good literacy in programming in Python. You should have written full training and test loops for applications that have significant data sizes in them, which means you know what tensors are, what the shape is. You've fought through the nastiness of weird shape things not plugging in, and you have to really step back and make sure you get the math of that, meaning and know how to use the NumPy software framework. And something crucial that every engineer needs to know how to do. What does an engineer know how to do? An engineer knows how to make things work. Nothing works when you first build it. You must debug it. Debugging is a whole skill that you have to have as a software engineer. How do you debug a neural network? Well, that's a big deal. It's not the same as what it was before. And so that's something you need to have touched before, or else you're just going to run into enormous trouble in this course. There are data science concepts that are fundamental to making systems and doing the project in the course. You should know what a false positive is, a false negative, a true positive, a true negative, how that leads to something called specificity and sensitivity. And then there's something called the receiver operating characteristic curve, and the area under that allows you to talk intelligently about trading off false positives and false negatives. And of course, the confusion matrix is a piece of that. All of these things are going to show up, and I'm going to be asking you to talk about these things in your project. So, after you finish this video, all students, whether you're on the waiting list or not, must go to and fill out this form. You can get to it. You'll have these slides will be accessible. This QR code will take you there. You must have a U of T login to reach that site. And it's a Microsoft Office form, and so it's probably good to start with forms.office.com. And you may have another Microsoft account. You should sign out of that because you won't get access, and then ask to sign in with your U of T email. Once you've done that, you'll be taken to the U of T main login, and you'll get access to the form. We'll be using forms throughout this class. 2 notes on this. First of all, you can only submit 1 response to the survey. The system will let you do more. And secondly, you may not use generative AI, ChatGPT, or any of its friends, which is ironic given the subject of this course, or the internet to answer those questions asked. And I'll figure it out, so don't do that. And I have more to say about the use of generative AI in the course. It's an interesting problem for us teachers. Let me spend a moment talking about my teaching philosophy. It is to teach less breadth, but more depth. And I'm keen to explain the intuition behind each approach, that I want you to try to make sure, given that you have the background knowledge, that to understand the essence of what's going on, because there's a bunch of things none of us understand, but we do know some things. And with this kind of solid, in-depth, intuitive understanding of things, that's the grounding that you can learn more on your own. And there's a lot that's happening, but the basics are the place to start. The second thing I believe is that learning comes from doing, from writing and working with software and experimenting with it. We'll talk about the theory and the ideas in the lectures, but in the labs and the project, you'll really touch the stuff. And by answering questions from those things that you experiment with, you'll be asked to think about what's going on. And as I've been alluding to, there's an open-ended project in this course. An engineer is someone who knows how to navigate an open-ended project. I really believe, quite aside from this amazing thing that we're teaching about in this course, the ability to execute projects is what makes you an engineer. And It is what will make you valuable and why people will want to hire you and or do research with you. And open-ended projects mean you have to conceive a project. We'll help you with that, but describe it in a way that makes sense to other people and has real logic in it, in the what and the why, and then executing it, to do it, to figure out how to get there from A to B, and then finally to describe it. So these things appear in all my courses, and this last one is it's not easy actually, but it is what makes you useful. So how are we going to get there? What's the structure of the course, and where do the grades come from? There are 4 assignments worth 40% of the course, and then the project is worth 60% of the course. And there's a bunch of deliverables in the project, a proposal document and in-class presentation, a progress report, a final in-class presentation, and a final report and delivery of the software. You must submit the software that you produce. And I'm also going to ask you to do what's called a peer review, where you evaluate other assignments a couple of times. So there's a lot of deliverables in this course. This is not a small amount of work. These are the 4 assignments. I won't go over them in detail. I'm involved in them, of course, each year. But the first one will be will be assigned as of the first lecture and due 13 days later. And that's a big assignment. And if you're a procrastinator that leaves things to the last minute, I guarantee that will be a nightmare for you. The textbook in this course is free. It's amazing. This Professor Jurowski and Professor Martin have been working on the 3rd edition of a famous textbook that's online at this link. It's called Speech and Language Processing. It's not quite complete. The first chapter is missing, but their 2nd edition is online, and you can read their first chapter there. It's just an introduction. There's a lot of computation involved in large language models, and certainly in deep learning, and you would know that if you've got the prerequisites. For the assignments in the project, I suggest that you at least purchase the 4-pay Google Colab Pro at $14 a month. And if you've got a little extra cash, maybe when you need it, go up to Google Colab Pro Plus, or you can also do a bunch of other things with Google Colab. It gets you the computing power that you might not have on your own computer. Let's talk about that project. First of all, the project will be done in groups of n. Normally, I like to say 2 there, but I don't know if the n is equal to 2. N will be a function of the number of students who remain in the class, and I don't know how many that will be, and the final level of TA support given to the course, given how many students remain in the course. So both of those things are up in the air, so I can't say what n is yet. The topic will be of your own choosing, but I have to approve it, and we'll end up having discussions around that. It has to be related to natural language processing and the material covered in the course, and it should be an application of natural language processing, although it is okay to do a project that is research-oriented, but that we'll have to have a deep discussion about, because the scope of research projects needs to be looked at carefully. And as you'll learn and you'll see online, there's 2 major classes of project, Class 1 and Class 2, and I'll go into more detail on that. It's in the documents that I'll be handing out, but also in the class discussion. These are the deliverable stages for the project. You have to form groups, you have to get approval in principle for the topic, give a proposal with a plan in it, and then present it, and then give a progress report and a final presentation and a final report. As I mentioned, there's peer review, which means I'll be asking you to watch other people's presentations and give them feedback and help them with it. A lot of learning that goes on in engineering isn't only about your own work, it's about watching what other people do and helping them and them helping you. And so this, I think, is an important thing. Let me tell you a little bit about myself and the teaching assistants so far in the course. My name, I told you, was Jonathan Rose. I've been a professor in this department of electrical and computer engineering since 1989. My research, most broadly spoken of, is the automation of medicine and mental health. And more recently, as I showed earlier on, it is the automation of mental health using machine learning and natural language processing, where I'm focusing on conversational systems for smoking addiction, and hopefully that will lead to systems for mental health. My previous field had nothing to do with this. It was all about field programmable gate arrays, FPGAs, if you know what those are. Hopefully you do. But I switched over into this one almost a decade ago. I also have some entrepreneurial and business experience. I co-founded a startup back in 1998 that was around FPGA software and architecture, and that company was acquired by an FPGA company called Altera, and I worked for that Altera from 2000 to 2003 as an engineering director, software engineering director. Altera was bought by Intel, and then this February, Intel spun it back out again and called it Altera again. I've been in administration in this university. I was the chair of the department for 5.5 years back in the 2000s. I am still the chair of the Engineering Entrepreneurship Hatchery Advisory Board. The executive director reports to me, and I oversee that as the academic oversight. And I'm strangely currently the acting principal of Massey College for this calendar year, so that'll be true until the end of this year. And I have a bunch of letters past my name, as you can see there. There are 3 teaching assistants. Jading Zhu is a PhD candidate under my supervision, and he's working on that smoking addiction chatbot. Zafar Mahmood is also an MASC candidate under my supervision who works on that chatbot and something we're calling a synthetic smoker, using an LLM to stand in for the smokers that we would deal with. And Weizhu Wang is an MASC candidate as well, working with Professor David Lee on security using large language models in coding. Those are the teaching assistants so far. There are 3 course websites. The Quercus one, which is the link of which is there, where you'll get the assignments released and submitted. You'll get your grades there and get announcements from there. There's a Piazza website for asking questions, link of which is there and also is linked to on the Quercus website. And there's a public website, as there always has been in this course for its first 2 years, that replicates most of this content. And so that's for others to look at if they want to watch the course. If you have questions, please post them to the Piazza discussion board for this course, although I can't answer a lot of them right now, or bring them to the first lecture, which is on September 10th from 9 a.m. to 11 a.m. in the OISE building at this location, room 2212, up at the north end of the campus. So I look forward to meeting you and seeing you there and then. Thanks.